As an introduction, a short video by Robeco Asset Management summarizes the current world water situation, mentioning Spain and the importance of urban design as a tool to reduce the water consumption.
Water, it's one of our most precious resources, but our water supplies are limited. 97.5% of the Earth's water is salty, and only 2.5% is fresh water. But over 2/3 of this fresh water is locked in the polar ice caps and glaciers. This leaves only 0.5% in our lakes, rivers and groundwater for agricultural, industrial and personal use. But due to pollution, the quality of this water is under threat. According to the World Health Organization, only 0.007% of the world's total water supply is safe for consumption, and this minuscule amount needs to be shared by the more than 7 billion people on the planet. And this water is not distributed evenly throughout the world. 1.2 billion people live in areas of water scarcity in places such as southwestern United States, India, Spain, North Africa, Australia and northern China. At the same time, demand for water is intensifying. As more people in developing countries move to cities, entire water distribution networks, sanitation systems and wastewater treatment facilities need to be installed, generating demand for pipes, engineering and construction. While in developed countries, an aging infrastructure desperately needs upgrading. Up to 30% of water in cities in developed countries is lost to leaks. But metering systems and advanced sensors can help utilities pinpoint leaks and fix them without digging up entire city blocks. But there are other ways to increase the available freshwater supply. Some countries in water-scarce coastal regions, such as Saudi Arabia, the United Arab Emirates and Spain, are turning to desalination to meet their growing demand for water.
Given this problem, what solutions can we apply to a city in Spain? Santander is a coastal city located in the north of Spain, with a current population of around 175,000 inhabitants. During the ISIS 1 project, we developed a concept model of 200 people per hectare and 800 people per hectare as an alternative to the real city structure. The site chosen corresponds to the city center, and it includes an area of 800 by 800 meters. The site was studied to understand how the city's layout works and then extract the main characteristics of the actual design. In our design model, we maintain one of the main roads crossing from east to west, and by a syntax analysis, we chose the busiest road to design another main road crossing north to south. Also, a current football field was conserved as the green open space in the central area of our proposal. The main roads have been designed to lead to the central part of our proposal. Most of the retail, commercial and offices are located along these roads. Secondary roads are located around the center, and they connect the 4 quarters of the city with the main roads. The site center is pedestrian only, and the 2 blocks at the east with the big open space have been selected for the development of this project. The area considered to draw up a detailed sustainable water management system includes only the 2 blocks gross area, and it achieves a density of 800 people per hectare. As a reflection of the ISIS 1 project, environmental aspects were identified as compromised. This, along with the importance of water, previously explained, made me work on a design proposal which vision would be what would the site look like if water management and solar energy efficiency were the main focus on the design. Water and energy are closely linked, and we need the first one to be able to manage the second one. Therefore, and with the intention of creating a sustainable design, solar energy will provide the framework and city layout to then implement a sustainable water management system. However, this is not enough for an urban development focused on people. We also need to create a good place. It is the combination of the 3 design objectives that will give us the solution. The street layout will be on angle from the east-west axis to maximize the solar gain. Presence of a big green open space in the center of the site with deciduous trees to both provide shade in summer and contribute to the reduction of the urban heat island effect. Mixed-use development along the main routes and within the pedestrian area with retail and restaurants on the ground floor and first floor, offices in the second and third floors, and residential apartments on the upper floors. The buildings range between 8 to 12 stories to increase the energy efficiency. Slightly taller buildings are located on the northeast side to protect from prevailing wind without overshadowing. A setback has been provided between 3 to 4 meters every 4 stories to increase this way the sunlight access in lower floors and create a feeling of more openness at the eye level. Urban breaks of at least 5 meters and with a height difference of 1 to 2 stories to allow sunlight into buildings, street and open space and to avoid wind funneling. PVT panels are installed facing south and only on the top of the tallest building of the block to not be overshadowed and to avoid a bad view for the building dwellers. The site will count with also window PVT panels on the southern facades of the offices. The energy obtained in the block will be enough for it to be self-sufficient in terms of electricity and heating. Each block will come with an insulation of a minimum of 300 mm to avoid heat losses in winter. The average of the dwelling's depth is 5 meters to allow the sunlight to access through. All the rooms receive sunlight and the communal corridors are naturally lit. Green roofs will be located in some of the lower buildings. The water harvested and recycled will be reused in the block buildings to flush toilets, shower, and washing machines functioning. These green roofs will be part of the social activity within the block and they are accessible by every dweller. Water-efficient devices are installed in the dwellings to reduce the amount of water used per person. The water not used straight away in the buildings and the water collected in the courtyards will be redirected to a system of reed beds in the block. The reed beds system is integrated as a water feature in the courtyards to recycle the grey water from the blocks and to act as a cooling system in summer. It also creates a pleasant view for the block dwellers. The recycled water will be piped to an underground storage tank and the process will be repeated in the 4 blocks. The underground tank will store the recycled water coming from the blocks and this will be pumped again to the buildings in scarcity times. Presence of an underground parking for each block that provides car space for the dwellers and that could absorb the extra amount of water in case of flooding to this way avoid urban damage on street level. A series of canals are incorporated as part of the urban features and they work as water retention systems. The system is similar to the swale functioning. It is an extension of the block's water management system and it is connected to the underground tank to send water during raining periods and to reduce such during summertime. They will cool the air and they will act as a recreation and visual amenity. Vegetation and tree lines are planted along the canals to reduce the water loss by evaporation. The ground is designed towards the main canal. Also, due to the topography of the site, infiltration devices such as swales are along the side towards the sea, so in case of storm rainfall, the water can be let and spilled in the sea. Presence of soft rather than hard ground cover, and high levels of planting trees and shrubs along the streets, and in the park to act as natural, sustainable urban drainage systems. Floor fountains are found spread with the design. These will cool the air in hot days and act as an urban attraction. A series of ponds connected to the main canal contain fauna such as fish and ducks that enhance the sensory richness of the area and meet different people's interests. These ponds will always have water as they can be fenced and isolated from the canal to conserve the microecosystem. All the energy invested in the water management comes from the sun energy harvested in the blocks, and therefore it does not increase the demand of electricity. The site has been designed with walkable blocks of between 50 to 100 meters long. The area is pedestrian only, with a walk path of a minimum of 7 meters wide on each side of the canals for emergency vehicles and for small delivery vans for the commercial and retail plots. There are active edges provided every 10 to 15 meters, and the entrance to the offices and apartments are located from street. This increases the activity and vitality of the area. The block corners are double-sided to increase the townscape richness with reflective views and to benefit retail and commercial plots to attract more people. Sitting space is spread throughout the site. Picnic tables in the green area, benches along the canals, and timber steps facing the water body. The latter ones are made of timber from silver ash, which is resistant to water and it participates in the character of the area. The open area has been designed to allocate different activities for children and families, young and elderly people. Tree lines are planted along the walk path on both sides of the main road and in between them to separate both ways. This reduces the pollution, the noise, and the visual impact. As part of the city's identity, each dwelling will have a private balcony overlooking either the street or the internal courtyard, and it is accessible from every room of the apartments, besides the bathrooms. 2 and 3 bedroom apartments are dominant in the development, and these are the most required flats in Spain. There is, however, presence of 1 bedroom studio and also maisonettes of 4 bedrooms, formed by 2 floors and with a private terrace accessible by the living room. This private open space acts as a private recreation area for the owners and it participates in the sociability of the block. Street lights within the area are sensible to movement. During periods of darkness, this creates a safe place and saves energy at the same time. Two design principles were partially delivered. Due to the need of providing residential space for a density of 800 people per hectare, the buildings had to be designed as one-sided to reduce the space needed for staircase and lifts that would have been necessary in a double-sided block model. Due to the central character of the site and the density requirement, only apartments are provided and no houses. There is, however, a wide range of different apartment sizes to accommodate diverse groups of people. Five elements were not delivered. The recommended street spacing of between 1.5 to 2.5, the building height, was not possible due to the requirement to accommodate 800 people per hectare. Due to the central location of the proposal, a combined heat and power station was considered as unsuitable because of the lack of space. Instead, PVT panels and PVT windows have been used to supply the development. As the street is not as wide as it was recommended, the use of large areas of tarmac as heat collectors has not been implemented. This would have been inefficient due to the reduced number of sun hours that it would have received. Under the current conditions, the water management system proposed is enough to supply the blocks and reduce the amount of potable water. If in the future the climate conditions make it needed, a provision of desalination plant run by solar energy could be placed in a non-central area of the city. Permeable paving to infiltrate the water and avoid runoff has not been designed. Instead, a canal system and a large amount of vegetation will prevent the runoff.